third mock, right?
Yes, sir.
This
Third
is
one.
third mock interview. So, okay, please introduce yourself.
Uh, yes, sir. Good morning, sir.
Good morning.
So I am Meet Arya. I am currently pursuing BTech in Information Technology from Walchand Institute of Technology. I am currently interested in machine learning and data science technologies. I have been working with Python since past 2 years and I'm comfortable in it. And in my free time, I like to play chess.
Okay. Okay. Can you tell me where we can use the linked list concepts in real-time example, real life?
Okay. Yes, sir. So linked list is what linked list is that we basically store our data in a node, and then we point that data to the next data that we are going to use in our program. So in real life applications, if we have a scenario where we don't want to keep a track of all the nodes at the same point, and we just want to know that what comes after the our current node, in that cases we can use linked list over there.
And in linked list, how the data or element how it stores?
So we can create a class which will save two. So if we have a singly linked list, then it will save only two. It will save two data. First one will be the data that we will be storing, and the other will be the pointer to the next node that we will be having in our linked list.
Okay. Can you tell me the different types of linked list?
Yes, sir. So first we have the singly linked list. Then we have doubly linked list. Then we have circular linked list.
What is the singly linked list?
In single linked list we store our data, and then we store the pointer to our next node. There is only one node, we can traverse only in front way, we cannot. So if we reach the next node, then we can't go back to our first node.
In doubly linked list?
Yes, sir. In doubly linked list we store our data, then we store the pointer to our next node, and we also store the pointer to of our previous node. So in that way we can traverse in both the sides.
Okay. Then is there any non-linear data structure?
Yes, sir. We have trees, and then we have graphs as non-linear data structures.
Okay, only two types, trees and graphs in non-linear.
Uh, yes, sir. Basically, we have these two, and then they can be further bifurcated as cyclic graphs and acyclic graphs.
What about
We can
sets
also
and
have,
tables?
yes, sir, sets, and then we can also have union and find.
Okay. Then in linked list types, like as you told now in graphs and trees. So in linked list, is there any types?
Sir, I think linked list belongs to linear data structure because we can traverse it in one way. That we can't have. Uh,
Means linear data structure types.
Okay, so linear data structures. Okay, so we have stack, then we have queue,
Okay.
then we have linked list.
Okay. Can you tell me some applications of data structure?
Yes, sir. Data structures is basic is why we need data structures is that if we have data for a specific purpose, then we can find out that purpose, and according to it, we can organize our data so that while performing those operations, we can retrieve our data very quickly. So
No,
if
where we can apply these data structure concepts?
Okay, sir. So if there is a case where uh, we need to implement the LIFO application, that is last in first out applications, in play, or let us assume if we have a if we want to maintain a queue of people that have entered a hospital, and we want to serve them on whoever arrive first can be treated first. So in that case, we can prepare a queue data structure for people who have arrived first, and then we can treat them first. So that works on first in first out principle.
Means are we using these data structure in machine learning or in signal processing or operating system or database management? Are we using data structure
Yes, sir.
concept?
Yes, sir. We use data structures in almost every field because those are basics of all the operations that we want to perform or that we want to achieve. So if we consider um, Okay, so if we consider operating systems, and if we assume that we are implementing a round robin algorithm, so we need to implement their circular queue, because there we are keeping track of all the processes, and then dividing them on the basis of the content time that we have fixed.
Okay. Is there any advantage or to handle the space complexity, time complexity for solving the problem?
Yes, sir. So um, okay, so sir, so if we assume that we need to implement a first in first out operation for any for any given problem, and if we are not using a queue in that case, and we are just using stack or linked list or any other data structure over there, so we are definitely losing our time complexity, because in a queue we can push and pop with O of one time complexity, whereas if we want to push and pop in linked list or any other data structure, we will be requiring more than that complexities.
Okay. What is the array?
Array is a simultaneous block of memory that we allocate to a similar data type of storage.
Then multidimensional array?
Multi-dimensional arrays, that is, we can store multiple arrays as in a single array. So if we have two, we can have 2D array, 3D array. So that will be storing data in a type of matrix.
Matrix, two dimensional.
Yes.
Okay. Then how these linked lists are more efficient than arrays?
Sir, it's actually depending on the type of operations that we want to perform. So, for example, if we want to perform, uh, if we want to perform insertion and deletion operation very frequently, like if we want to insert anywhere in the middle, or if we want to insert anywhere in the end, in that case we can't use linked list, because linked list is mostly used for traversal and the searching of our data, because there we keep track of all the nodes that we are having in our linked list. So in that case we will be using linked list, and for frequent insertions and deletion operation we can use arrays. So it's not like one data structure is better than another, we can use both of them as per our requirement.
Okay. What is stack? And you just explained with some applications.
Okay, so stack is a data structure which works on the last in first out principle. So what happens is that if we are storing data on top of in top of each other, like the data which enters first will be taken out in the last. So for example, I will be considering. Okay, so the most common example for stack is the parenthesis checker. So as we know that if we want to find an equation, if the equation is having same number of brackets and the brackets are in the same order, what we can do is we can add our parenthesis into our stack, and then when we find the closing tag for that parenthesis, we can just pop that from the stack, and if at the end is stack is empty, then we know that our equation is like correct, and if the stack is not empty, or if we are not finding any matching parenthesis, then it's not correct.
And how this stack is different from the queue?
Yes, sir. So queue works on first in first out system, and the stack works on last in first out operation. So what a queue does is that it inserts data from one end and then it pops data from the other end. Whereas what stack does is it insert data in from the one end, and also it pops the data from that same end.
Okay. Okay. And just tell me some process like the behind storing a variable in memory. What is the main process behind this? Storing the variable in a memory.
Sir, so what happens is that first we need to initialize our variable. So initializing means we need to define the data type of which. So if we want to store a character type of data, then our operating system or the kernel will be allocating. So if we want to store a character, then it will be allocating 1 byte of memory somewhere in the in our memory system, and then address of that memory system will be assigned to that variable that we are creating over there.
Okay, means first it allocates a memory.
Yes, sir.
Okay, then how to implement a queue using the stack?
Okay, sir. So if we want to implement a queue using, sir, we can use two stacks for that. So as we know that a stack can only insert from one node and then pop that from the same node. So what we can do is we can create two stacks, and then while insertion we can insert data in our first stack, and if we want to pop, then what we can do is we can pop our whole stack from first stack to the second stack, and then we can just pop
Can you
only
write
for.
one pseudocode for this?
Yes, sure, sir, sure, sir.
You just share the screen and in
Okay, sir.
Notepad. So here we like, do you perform NQ DQ operation?
No, sir. Here we don't perform NQ-DQ operation because we are using stack to implement a queue. So behind the mask we are using push and pop operation, but for the user we are performing NQ and DQ operations.
Okay. You just
So, sir,
increase the font size and rate as like pseudocode for this. Means like implementation of queue using the stack.
yes, sir. So we can have a stack one and a stack two, and what we can do is we can create a class called as queue. So when user does an NQ operation, so like if we create a variable as q1 equals to q, and then a user does q1 dot nq1. What happens behind the mask is that we create a function over here as def nq. What this does is it will insert in our first stack, which is stack dot append n. And when user does, we can assume that user is performing few more nq operations. Okay, so in that case we will be our stack will be having 1, then it will be having 2 and 3 in this manner. Okay, so if user then does q1 dot dq,
Okay.
so in that scenario what will happen is we can iterate a loop like while stack 1 is not empty, so while stack 1, we can do stack 2 dot append stack 1 dot pop. So what this will does is it will take the top element of our stack and then append it to the bottom of our queue of our second stack, and then we can create a variable called something as element equals to stack 2 dot pop. So this will return the first element which was on the top of stack 2, and then we can create another while loop while stack 2, and then append this whole thing back to stack 1 dot append stack 2 dot pop, and then we can return this element.
Okay. Can you tell me what is hash map in data structure?
Yes, sir. Hash map basically works like a dictionary, and it will store all the occurrences of the characters that we are having in our uh, we are having in our list or string or whatever we have, and then we can retrieve that data in O of 1 complexity.
Can you store duplicate key in hash map?
No, sir, we cannot store duplicate key because it works as a dictionary. Only unique keys can be there. What we can do is if we want to store same data for you for that key, we can create a list for key of that value and then we can append to that list.
Okay, okay. And then what is a tree in data structure?
Uh, Tree comes in a non-linear data structures. What happens in tree is that we create a node, and then each node can have multiple childrens over there, and each children can then further have all the further have childrens of it.
Okay. Can you tell me some applications of tree?
Yes, sir. So applications for tree. So as we all know, the binary sort which works on n-log n complexity, that uses a tree. What happens in binary sort is we sort the data on the basis of the middle element. So what happens in binary tree is our root node, the child of the left node, the left child of our root is always smaller than our root, and the right child of our root is always greater than our root node.
Okay. Can you tell me some applications of tree,
um
like
tree
file system, like files inside a folder? That
Okay, sir. So,
like,
yes, for disk memory allocations, we use their B trees and B plus trees in that case for memory allocation in disks.
okay. And what about the comments in social media? Eh, Can we form a tree
Um,
with the comments
Sir,
and reply?
we can form a tree there as well, but what happens is social media network is like a group of connections or multiple connections. In that case, what we can have more than two three children. So like a single user can have a lot of friends, and that friend can also have some other friends, and they which will be mutual between them. So that can cause cycles between them, and in a tree that is not allowed. We cannot have cycles in our tree. So in that case, we try to use graphs in that case.
Okay. What are the binary trees?
In a binary tree, we can only have zero or two children, and the left child of our root node is always must be smaller than our root node, and right child must be greater than our root node, and it has to be same applicable for all the subtrees that we will be having below.
Okay. Can you tell me the maximum number of nodes in a binary tree of height k?
uh, Height k, it can be sir, we have two nodes at, so we can have 2 to the power k, uh, 2 to the power k, maximum 2 to the power of k. Okay, so we have only one node at the zeroth level, so it will be having 2 to the power k minus 1 nodes.
2 to the power k minus 1.
Yes, sir. Because on the root node we will be having only one node over there, so we need to subtract minus 1 on there.
Okay. Suppose if the height is height is 1, then
So if the height is 1, which means we have a root node, then we have two children further. So there we can have three children, and 2 to the power 1 will be 2 minus 1. So okay, uh, that's not the correct formula. Uh, um, Three children. So
it is 2 raised to k plus 1 minus 1.
yes, sir. It can't be minus 1 because then we will be having only
No, it is
one
2
child
raised
as well.
to k plus 1 minus 1.
Yes, sir, k plus 1, but not minus 1,
Oh,
just plus 1, because 2 to the power k will be further k. So we consider our root node as zeroth level, and then we further go on as 1, 2, 3, 4 level. So we can have 2 to the power k plus 1 children.
okay. So can you tell me tree traversals?
Okay, sir. So there are three types of tree traversals. We have pre-order, we have in-order, and we have then post-order.
What is in order?
In order, what we do is we first visit our tree uh, left our tree in the left side, like complete left side, and then we check our root node, and then we check our right side of the tree.
Okay. In pre-order.
In pre-order, we check our root node first, then we go to our left side and then right side.
Okay. And in the post order, left.
And in post order, we go for the left, right, and then root node.
Okay. Okay. So you like you open a notepad, like open a paint application. Okay. So you use some circles. Okay, for writing the notes. Okay.
Okay, sir.
One circle, then left and right, another two circles. Okay. And again for the left, again two. Okay.
Here as well.
Yeah. No, okay. 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 Enough. Then in the middle of the node number you write down. Use that A. Okay. One, and here two and three. Okay. And there four and five. Four and five. Okay.
Okay,
Just
sir.
can you zoom it? Uh, okay. Okay. No problem. You just write down the in order, pre order, and post order for this.
Okay, so
You
for in
just
order.
connect it you by
Okay,
using the
okay,
line.
sir. Okay, so
In order, left, root, and right.
yes, sir. Left, root, and then right. So we will be having one, then left, and left, and so we'll be having four. Then we will be having root two, then five, one, and three. Okay, so then in okay, so I will write pre-order about this. Uh,
Increase the font size if possible, or there in the, yeah, yeah. Okay.
in pre-order, what we do is we first go to our left and right, and then our root node. So uh, we first write no, first we visit our root node, then left, and then right. So first it will be two, one, then our left child will be two, then four, five, and then three, and then post order traversal. We first go for the left, right, and then root. So left will be four, five, root is two, three, and then one. Yes, sir.
Okay. Okay. Now, can you tell me different topologies in computer network?
Yes, sir. We have two types of topologies. That is, first is physical topology, and the other is logical topologies. In physical topologies, we have uh, bus topology, we have star topology, we have mesh topology, we have ring topology, and then in logical topologies, we have the LAN connection, then MAN connection, WAN connections.
Can you tell me difference between the OSI model and the TCP/IP model?
Okay, so in OSI model, we have first the major differences. The OSI model is having seven layers, and TCP/IP model is having five layers in that case. The OSI, the application presentation and the session layer in OSI model has been combined to only one layer in uh, TCP/IP model, which is application layer. And
Can you
other
tell
than
me the functions of transport layer?
functions of transport layer. Um, Sir, function though in transport layer. So we have in transport layer, sir. What happens is we attach the MAC addresses of the sender and the receiver uh, uh, computers or the devices to our data frame, and then we send that data over to our network. I think that's for network layer or for transport layer. I'm not very sure for that case.
What is the the data type here in transport layer? What it does?
Sir, we have
How it get the data? Yeah.
segments in transport layer.
Okay. It means it segments and reassemble the
Okay,
data.
okay. So I just recalled it. So what happens in transport layer is that we attach our data along with the sequence number and the port number. So sequence number, what it does is it will keep a track of all the data frames, data that will be retrieving to the other PC, and what the uh, uh, port number will does is it will mention that which application, which network application will be using this data.
Okay. Can we ensure integrity in data integrity in transport layer?
Data integrity, sir. We have uh, two types of protocols in transport layer, that is TCP and then UDP. So what TCP does is after the data has been received, it gives an acknowledgement to the sender that the data has been received, but that's not the case in UDP. So if we are using UDP, we cannot assure that all our data has been sent.
Yeah, means in TCP we can ensure the data
Yes, sir,
integrity.
because if
Okay.
data is not received, it will be sent again.
Okay. What about network layer?
In network layer, what happens is the data from the transport layer then reaches to network layer, and the IP addresses of the sender and the receiver are being attached to our segment, and then the whole data will be called as a frame in that case, and that will be further proceeded to our data link layer.
Okay. Can you tell me what are the different protocols used in the network layer?
Uh, So one of the roles of network layer is to find the shortest path that we will be using from our source to our destination. So in that case, we will be using open shortest path first protocol, which is OSPF.
Okay. Then application layer protocols.
In application layer, we have various protocols based on the type of application which we'll be using. So if we are using application for our web surfing, we will be using HTTP and HTTPS protocols. If we want to send mail, then we will be using SMTP protocol. If we want to perform file transfer, we will be using FTP. For video calling or something, we will be using Telnet.
Okay. Can you define unicast, multicast, and broadcast?
Sorry, sir. Unicast, multicast,
The
and broadcast.
multicast and broadcast.
I'm not very sure what this is, but for broadcast, what I know is that if we have a connection, if we have a local area connection, or if we have a network, then broadcast, what it will does is it will send that particular message or data to all the hosts that we are having in our network.
Okay.
And I
The
think that will be reverse for unicast, that only the receiver will be having will be receiving that one message.
single destination host.
Yes, sir. Single destination and single receiver.
Can you tell me the difference between half duplex and full duplex?
Yes, sir. In half duplex and full duplex. Uh, Sir, I know for full duplex, but I can't recall the half duplex. In full duplex, what we can do is we can send and receive data at the same time.
Simultaneously in full
Yes,
duplex.
sir. Simultaneously input and
Full duplex or half duplex?
full duplex, sir. Sir, I'm not sure what half duplex works or how that works, sir.
Are you sure in full duplex it is simultaneously?
Um, Sir, in duplex, yes, sir. We can receive and send at the same time in duplex. Wherein in uh, single copper wire, we can only send or receive at the same time. Uh, yes, sir.
You mean to say in full duplex the data like send means it in both the directions simultaneously.
Yes, sir. In full duplex.
In half duplex,
I'm not sure for half duplex, sir.
since here it is opposite, it is not in simultaneously at a time only one direction. Like
That's true for
walkie-talkie,
single
walkie-talkie, half
single
duplex.
copper wire, but I'm not sure for
No,
half.
no, that walkie-talkie is there, no, in one direction.
Okay,
Example. So
okay,
that is
okay.
that is
Walkie-talkie. Yes,
half
sir.
half duplex.
Yes, sir.
Okay. Okay. Next, in operating system, can you tell me different type of operating system?
Uh, we have Mac OS, then we have Windows and Linux.
No, the not these type of operating system.
Okay,
That
then okay, so we have a single processing operating system, and we have multi-processing operating systems.
okay, like multi-threading and all.
Yes, sir. Multi-threading, we cannot achieve multi-threading in single processor because there we have only one processor which will be executing all of our tasks. That can be done in multi-processing operating systems.
What about distributed operating system?
Distributed operating system. No, sir. I don't
What is
recall
kernel?
that. I'm sorry, sir.
Kernel.
Kernel. Okay, sir. So what so if we have any application running our operating system, so to maintain the integrity of operating system and to communicate with it, we have a layer between operating system and those application, and which is called kernel. What kernel does is it talks with our applications and then converts those message and tells it to operating systems.
What are the different states in a process? States of process.
Uh, First, we have the ready state. So when a process has arrived and it is ready to be executed, uh, then it can be in waiting state. So if it is waiting for any input or output operation, it will be in waiting state. Then it can be in executing stage. So if the process is currently being executed by our CPU, and the final stage is, I think, completed or finished stage.
What is paging in operating system?
Yes, sir. So what happens is our process can be the size of our process can be greater than the size of our frame, which is in our uh, memory management or memory allocation system. So if we have a frame of memory which can store only like 1 byte, and we have a process which is of 4 bytes. So what paging does is it will separate our process in four 1 bytes of process, and then that will be stored in our memory, and track of the addresses of those pages will be stored somewhere, like the order in which they are process has been separated. So that process is called paging.
Okay. Okay, in the pad in this paint, you draw one pattern. Okay. If
Shall I clear this all?
no, you just write down in the right side. Okay.
Okay, sir.
You write a pattern. Okay, you write down one.
Yes, sir.
Okay, in the next row, uh, two. No, you write it in a triangle form.
Okay, sir.
So yeah, next four. So next again four. Again four. Okay, next 16 four times. Oh, okay. You can you
Okay,
write a
okay.
program?
Yes, sir. I got the pattern. Um, so these are the power of twos, and okay. So first our n is okay. So we are multiplying. We are taking where no 2 to the power 1 is 2, then 2 is 4, 3 is 8, but that's missing in this case. So the
Is it possible to draw to write a program for this pattern?
sir, we can exclude our first level, which is 1 in this case, and then write the pattern for our other levels, because what happened in this case is these are the power is these are like squares of the previous level. So if we have 2 in this case, we have square of 2. If we have 4 in this case, then we have square of 4, which is 16 in this case. But if we do square for 1, we will be getting 1 itself and not 2 over here. So if we print 1 separately and then perform our this pattern for just 2, 4 and 16, we can do that.
Means with as same pattern is not possible.
No, sir, we can't perform it, because if we have another layer for 8 in this level, then then this is possible, because then it will be a pattern for powers of 2.
Have you tried that Pascal triangle?
Yes, sir, I have tried it, but like for using loops.
Hmm.
uh, yes, sir, I tried that on that day, but I think I have to recall it once again, because Pascal triangle. Yes, sir, I can do that now as well.
No, no problem. See, what happens is you may get like coding questions. Definitely, you will get in the interview. Okay.
Okay, okay, sir.
So, like, try to like at least 100 to 150 programs. You just revise it. That
Okay.
all such type of at least basic and medium level programs you should know. Okay.
Yes, sir.
Means you can do it in one day. That all the if you can revise all the 100 to 150 programs with basic level. Okay. So just revise it because it is very, because definitely you will get one or two questions in the coding. Means with the different, like suppose just now I told some pattern. Okay.
Yes, sir.
uh, so actually suppose if this with the same pattern, if we rate like in first row 1, then 2 2, then 3 times 3, then 4 times 4, then you can such type of you have done.
Yes, sir.
But the interviewer they can ask any type of questions. Okay.
Yes, yes.
So try to practice it. Okay, coding. So you compared to your first and second mock, you are almost you are done some like revised some of the concepts in computer
Yes, sir.
network,
Actually,
data structure, and
in
all.
my first mock, I was not very clear with
Yeah.
my core subjects concepts. I have did that now.
No, it is okay. But you just but still you continue that. Okay, you
Yes, sir.
continue the
Yes, sir.
revise that one, and also like the basics you can do, but in the coding. Okay, but still you can just revise the some coding questions. Hmm?
Yes, sir. Yes, sir. Sure.
Okay. Because what happens is you are already now